So the first question that we want to ask is, what kind of information can we get out of a function that goes beyond just the values that that function takes, just the relationship itself between input value and output value? What we really want to know is how a function encodes information about change. And change is really the main idea of the whole first half of calculus, the first half of calculus that deals with a topic that we call derivatives. So we're going to use the idea of marginal functions in our business decision-making project to motivate a mathematical study of derivatives and tangent lines. So that's where we're going with this today. And in the process, we're going to also move off of just thinking about the demand function, which relates price to quantity, and we're going to move forward and look at the functions which we can build on top of demand, namely revenue, cost, and ultimately profit, which is the main idea of the marketing project. So first of all, what is a marginal function and how does it work? So let's take a quick look again at our demand function. So here's mine. It's a quadratic. Here are the coefficients that we got out of the quadratic fit for it. And the function itself tells me if I choose any given quantity that I wish to sell in the national market, let's say I want to sell 800,000 of my product, then it tells me what price per unit I would have to charge in the market in order to sell that much. So if I want to sell 800,000 units, I would need to charge $264.31 per unit in order to sell that many in the national market. So that sets up a relationship between quantities, a relationship between the value of Q and the value of P. The question that we ask when we do marginal analysis, though, that question is really a question about change. And so I want to motivate it like this. The question is, suppose that I'm actually suppose that I'm actually producing 800,000 units of my product. The question I ask in marginal analysis is an if question. If. So if I were to increase my quantity of production by just 1 unit. So I'm currently producing 800,000. If I wanted to produce 800,001, then the question that I ask in marginal analysis is, what's going to happen to the value of my output, which in this case for a demand function is the price. So what happens to my price? We decided in our last class that demand functions generally have this property that if I want to sell more, if I want to increase my quantity, generally I'm going to have to drop my price in order to do that, right? A higher price is going to lead to fewer sales and vice versa. A lower price generally will admit more sales. So this is a reasonable question to ask. If I increase the quantity that I'm selling by just 1 more, so if I'm making 800,000, I want to sell 800,001. The question is, what am I going to have to do to my price? We know we're going to have to decrease it, but decrease it by how much? So one way to think about how to answer that question would be to just zoom in on this graph. After all, if I'm increasing my quantity by just 1 unit, Q is measured in thousands here, so really I'd be asking about a production not of 801, but of 800.001. One way to do that would just be to zoom in on that point as much as possible. Keep going, keep going, keep going. By the way, you notice that the further that we zoom in on this point, the more that our graph, which when we were looking at it on the whole, our graph looked like a parabola, right? This quadratic U-shaped graph, even though we couldn't see the whole U. The more that I zoom in on this graph, the more that my graph just looks like a straight line. That's super meaningful, by the way. And it's something that we're going to come back to in a little bit. But if I keep zooming, keep zooming, keep zooming, all right, now I think we're in far enough that we'll be able to see what it is that we're looking for. Weirdly, my point looks like it's slightly off of my graph a little bit. Sorry, that's a bit of a round-off error in my function. So the question I want to ask again is, if I move forward from 800,000 units of production to 800,001. In other words, if I just bump this forward to the next point, 800.001, what's going to happen to my price? So the idea, I'm going to move this so that it actually lines up with the graph a little bit better. So here's my point at Q equals 800. Here would be my point at Q equals 800,001. In other words, 800 0.001. And we know that the y value at this point, this was 264.311. This looks like it's maybe 264.3105 or something like that. I'm just kind of estimating based on what the graph looks like. 264.3105. All right. So if I produce just one more unit, then I have to drop my price ever so slightly. We might not even notice the drop in price at the level of dollars and cents, because this is 31 cents. This would also round to 31 cents. So it's such a small movement in the unit price level that we might not notice it if we were actually bringing this to market. But we would certainly notice the aggregate effect of selling 800,000 units at this price. That is going to actually change the amount of sales revenue that we make. But when we do marginal analysis, the question is really a question about change. It's a question about the relationship between the increase of 1 unit in production and the decrease in price, in this example, that comes along with that increase, and being able to quantify that difference. The way that I would do that is by subtracting this amount of price, 264.3105, minus the amount of price that we had in the beginning, right? If I want to measure this vertical distance, I should just subtract these two vertical values, the two y values of these points. If I do that, I'm going to write that calculation up here, 264.3105 minus 264.311. What I'm going to get is negative 0.005. I think that's what I'll get. No, 0.0005. There we go. So I'm going to get some really small amount, and since that's a difference in price, the units on that are in dollars per unit. So what we're saying is that as the quantity I produce goes up by 1 unit, the price that I can charge goes down by this little fraction of a penny. And if I want to turn that into a single number, what I can do is divide. Divide the change in my y values, my negative 0.0005 dollars per unit. My vertical change, I'm going to divide by my horizontal change, plus 1 unit of sales. And I'm going to get a quantity that looks an awful lot like a rise on the graph divided by a run on the graph. This is a kind of quantity that we've met a number of times in algebra and also in pre-calculus, and it's super important. It powers the whole first half of calculus as well. When I divide a rise by a run, what I get is I get a slope. And after all, since we zoomed in so far into our demand graph that it looks an awful lot like it's just a straight line, that slope is measuring the slope of this little straight line segment, this teeny tiny little straight line segment that joins these two different points on the graph of my demand function. So if I divide this out, I get something that looks like minus 0.0005 dollars per unit divided by units. So I'm just going to call this dollars. Okay. And so let's put some context onto this. What this really tells us, first of all, we call it the marginal demand. Marginal demand. And we would represent it by MD. So capital M in front of my demand function. Now I'm talking about the marginal demand. And this is evaluated at a quantity of 800. And the number that I got was minus 0.3 zeros and a 5. And so this tells me, again, if I put some context onto this, that if we're producing 800,000 units, 800,000 units, then to sell just one more, we need to drop the price. Drop the price, the unit price, by this amount, $0.0005. Right? So this is telling me something about how the demand function, the green graph here, encodes a rate of change. Right? It tells me the slope of this graph at the point Q equals 800. And so it's anytime in business we talk about a marginal analysis, a marginal function, we're really asking the question, what happens if I want to just sell one more, just produce one more? What's going to happen in this case to my demand, the price that I have to charge in the market in order to sell that one more? And this is the same kind of analysis that we can also do, not just with demand, but also with revenue, with cost, and ultimately with profit. And it's that kind of analysis that's really going to drive the next couple of decision reports in the project. So before we go further off of this, let me take a pause. We'll stop this video and ask if there are any questions before we advance.